Today's lesson is 6.4, and it's titled Solving Word Problems Using Systems of Equations. So there are two types, one that I'll call things and one that I'll refer to as total. The steps are the same. We're going to make sure that we assign x and y and write them down. We want to set up two equations, and then we'll solve using substitution or elimination, and then make sure that we answer the question at the end. So when we set up a things type of problem, we're going to have two equations where we're trying to calculate the price of the two different items. And so we'll look at situations where there's a certain number of each one and it equals a total price, and then set up the second equation where there's a different number of each one, again set it equal to the total price, and then we'll be able to calculate how much each item costs. So in the first example, 5 pencils and 2 pens cost $2.75. And 5 pens and 2 pencils cost $3.20. So we're going to find the price of a pen and a pencil. So we're talking about pens and pencils. We want to know the cost. So X and Y are going to represent the cost of a pen and a pencil. And you get to decide here, do you want to make X pens or pencils, and then Y would be the other one. I'll go ahead and do X will be the cost of a pencil, and Y is going to be the cost of a pen. So in the first situation, 5 times X for 5 pencils plus 2 times Y for 2 pens is going to cost $2.75. The second equation, 5 pens and 2 pencils, so that's 2X plus 5Y is going to cost $3.20. When we're working with this type of the story problems, you'll have to multiply both equations by a number in order to get them to eliminate. I'm going to go ahead and do elimination here. So I'm going to multiply the first equation by -2 and the second equation by +5. I'm going to get my x's to eliminate by putting a -10 and a +10 in front of them. Again, it's your choice if you want to eliminate x or y. You should get the same answer both times. So the first equation, I have -10x minus 4y, and that equals -$5.50. In the second equation, I have 10x plus 25y, and that equals $16. So now my x's will eliminate. -4y plus 25y is 21y equals -$5.50, and $16 is $10.50. Dividing both sides by 21, we get that, I'll write it over here, y equals 0.50 or 50 cents. Now I need to figure out the cost of a pencil. That's the x. So I'm going to plug that 50 cents in. I can do it in either equation. I'll go ahead and just use the first one. So I have 5x plus 2 times 0.50, and that equals 275. So 5x plus 1, subtracting 1 from both sides, 5x equals $1.75, and dividing both sides by 5, we get that x equals 35 cents. And so we want to make sure we go back and answer the question always. We don't just leave our answer as x equals and y equals. So a pencil, that's the x. So a pencil costs 35 cents, and a pen costs 50 cents. So let's look at another one. We've got a math club. They spent $135 buying 6 cases of juice and 1 case of bottled water. The science club spent $110 buying 4 cases of juice and 2 cases of bottled water. How much did a case of juice cost, and how much did a case of bottled water cost? So x is going to represent the cost of, I'll do a case of juice, and y is going to represent the cost of a case of water. It is important that we write that down. We just don't want to get mixed up at any point. So we have 6 cases of juice and 1 case of bottled water. So that's 6x plus y equals 135. And then we have 4x plus 2y equals 110. Now this is one that's actually going to be kind of nice because the y has a coefficient of 1, so I'm only going to have to multiply this first equation. I'm going to go ahead and get the y's to eliminate, so I'm going to multiply it by a -2. So that's -12x minus 2y equals -270. And then I'm going to leave the second equation as is. So -12x plus 4x is -8x. -270 plus 110 is -160. And dividing both sides by -8, we get that x equals 20. And now I want to figure out what y is, so I'm going to go ahead and take that 20. I'm going to plug it into the first equation because that's where I have just the single y, so I won't have to divide. 6 times 20 plus y equals 135. So that's 120 plus y equals 135. Subtracting 120 from both sides, we get that y equals 15. It's probably a little unrealistic. Cases of water don't actually cost that much money, but here we go. So now we need to write our answers to the equation. So a case of juice costs $20, and a case of water costs $15. So those are 2 examples for the things type of word problems. Now we're going to look at the total type. When we solve, when we set up our system here, we're going to typically have one equation that will just be x plus y. That's the part plus the part. However many of x plus however many of y is going to equal the total. And that's not price, it's just the total of however many items have been bought or used. And then in the second equation will be another price type of equation where we know how many of one plus how many of the other, and we know the total price. So Steve asked a bank teller to cash a $390 check using $20 bills and $50 bills. If the teller gave him a total of 15 bills, how many of each type of bill did Steve receive? So we're talking about 20s and 50s, and we're trying to figure out how many he got. So x here, I'll use x to represent the number, oops, spell it correctly, number of $20 bills, and I'll use y for the number of $50 bills. So remember, we always said that one of the equations is just going to be an x plus y. So the number of $20 bills plus the number of $50 bills should equal the total number of bills he got, which was 15 of them. And we know that a $20 bill is worth $20 and a $50 bill is worth $50. And when you figure that out, he got a total of $390. This type of word problem, this type of setup is usually a little bit nicer because we just have the one equation that we can multiply. We can either multiply it by -20 or -50, depending on if you want to eliminate x or y. I'm going to go ahead and multiply by -20, it just keeps the numbers a little smaller. So we have -20x minus 20y equals -300. And then 20x plus 50y, I'm just rewriting that second equation, is 390. So again, our x's eliminate, so 30y equals 90. And dividing both sides by 30, we get y equals 3. These are also usually a little bit easier to find the other variables. So if y is 3 and he had 20 or 15 bills altogether, then x is going to be 12. And you can get that from plugging 3 in for y and then subtracting 3 from both sides to solve for x, and we get x is 12. So he got 12 $20 bills and 3 $50 bills. And that's the only combination of bills that would work like this, where he got 15 total bills that equaled $390. We've got one more example. To use a certain computer database, the charge is $30 per hour during the day and $10.50 per hour at night. If a research company paid $411 for 28 hours of use, find the number of hours charged at the daytime rate and at the nighttime rate. Usually the question will help you determine what your variables are going to represent. So x is going to be, I'm going to do a little bit of abbreviating here, number of daytime hours. And y is going to be the number of nighttime hours. And so again, because this is a total type of equation, and I know that because I don't have a situation where, or I don't have two situations that both deal with money. So x plus y, the number of daytime hours plus the number of nighttime hours is going to equal 28 because it says 28 hours of use. And if it's $30 for each daytime hour and $10.50 for each nighttime hour for a total of $411. So we're going to multiply that top equation. Again, we can multiply by -30 or we can multiply by -1050. Now I'm going to go ahead and do -30. Just seems a little easier than having to mess with that decimal. So we get -30x minus 30y equals, I don't know what 28 times 30 is, -840. And then my second equation is unchanged. You just want to be really careful with your signs here. So the x's are going to eliminate. -30 plus 1050 is -1950 y, and -840 plus 411 is -429. I'm going to divide both sides by -1950, and we get that y equals 22. That means there were 22 nighttime hours, and again, we know that there were 28 hours altogether, so we just do 28 minus 22, and I'm just showing you how to plug that back into the equation. A lot of students can end up kind of skipping this last step here, and we get 6. So then we want to write out the answer. So there were 6 daytime hours and 22 nighttime hours. So really the newest part we've taught today is just the 2 different types of word problems that we'll be looking at. And once we get them set up, then we're just doing elimination to solve them. You're welcome to use substitution, but elimination is typically going to be the easier of the 2 methods. So I will check your notes in class, and we will work on worksheet 6-4.